All right, so our topic for today, we're looking at our last method for visualizing quantitative data. That's using the box plot. Sometimes we call it a box and whisker plot. We're also going to look at how you calculate an outlier. So first up, we see this language of the 5-number summary. So we're looking at the smallest observation, the smallest data point, that's the minimum value. The lower quartile, that's the Q1, same as the 25th percentile. The median, the midpoint of our data, where does it split it into 50% below, 50% above? Also think of that as your second quartile or your 50th percentile. The upper quartile, the Q3, the third quartile, or the 75th percentile. And then the largest observation, the maximum data point. Visualizing all of this in increasing order. So here's the shorthand for all of those words. In the calculator, we'll see minimum show up as the min. Q1 is the Q1. Your median, sometimes we see it as MED or Q2, right? Second quartile. Q3 is the third quartile, and the maximum is also the max. Okay, next, when we look at a box plot or box and whisker plot, we're just looking at a visual representation of that 5-number summary. We start by making a number line. So let's all do that together. So let's say that I use centimeters. Let's say that I mark from 0 to, I'll go to 14, just like that. I'm going to mark little notches at all of those increments. And then add labels. So I'll make this my 0, 1, 2, 3, 4, 5, all the way up to 14. Okay, so once I have my number line, let me just slide it up to here. We draw a box from the lower quartile, the Q1, to the upper quartile, the Q3. We draw line segments connecting the box to each extreme, the max and the min, and draw a vertical line to indicate the median. The segments at either end are the whiskers. Okay, so let's imagine first, let's just plot a point for each of those 5 numbers. Let's say that in my distribution, I had a low value of 0. This is the minimum. Put a little dot right there. Let's say that my Q1, my first quartile, was 6. Let's say that my median, the second quartile, was 7. My Q3, my third quartile, is 8. Okay, and then the maximum value is 14. All right, so again, I'm just putting little dots at my 5-number summary. So then I like to draw the box part next. So with my straight edge, I'm going to draw a little vertical segment here and here. Okay, connect to finish up the box part of it. Okay, draw in the whiskers next. Okay, and then a vertical segment right here for the median or the Q2. So right here, this is my min at 0. Here is my Q1, my median or Q2, my Q3, and my max. So in the visual that I'm giving you, what it tells me is how widespread my data is. So this whisker right here shows me that I have 25% of my data that's spread out between 0s and 6. Right here is my interquartile range, my box, because it's spanning from my first quartile to my third quartile. So this is how spread out the middle 50% of my data is. Here is 25%, right? This is between the Q1 and the median, but it shows me that I have 25% of my data that's in between 6s and 7s, and I have 25% between 7s and 8s, and then I have more widespread data over here in that upper whisker, right? So the wider it is, the more spread out my data is. The closer together, the more concentrated my data is. So if I was looking at this as a histogram, I would expect it to look symmetric and unimodal because I have a tight concentration of data in between 6 and 8, right? That's half of my data. So this would present, unless I have outliers present, so assuming no outliers, this would look unimodal and symmetric, bell-shaped, if I was visualizing this data as a histogram. But the presence of outliers can really alter the visual of the box plot or box and whisker plot. So we need to address that next. We know conceptually that an outlier is a piece of data or multiple pieces of data that deviate from the rest of the group. So something that is an anomaly. We have goalposts that we set for what makes something an outlier. So here we say that it can be any value that is smaller than the Q1 minus 1.5 times the IQR. So any low outliers would be less than the first quartile minus 1.5 times the IQR. Okay, the other option is we could have a data point that is larger than the Q3 plus 1.5 times the IQR. So any high outliers would be more than the Q3 plus 1.5 times the IQR. So let me go back to this visual right here. So what that's doing is it's taking the IQR, in my example, that would be 2, right? 8 minus 6 is 2. Okay, it's multiplying that by 1.5. So it's taking this width and adding on an extra half. So it makes it go 3 units wide, whatever my context is. And then it's attaching it to the Q1, so going out 3 units here. Any data point here that is further away than right here would be considered an outlier. So this means I must have an outlier in this distribution. And if I take again this span multiplied by 1.5, so add on an extra 50%, make it 3 units wide, and I attach it here, anything beyond this goalpost would be considered an outlier. So that means I must have a high outlier over here as well. So again, visually, I'm taking my box, which really translates to my IQR. I'm making it 50% wider, right, because I'm multiplying by 1.5. So I'm looking at it as 3 units. And if I add 3 units here to the Q3, anything in here would be considered an outlier. Add 3 over here, right? Anything beyond here would be an outlier as well. So in my visual, must have some outliers. Let's do an example. So here I have test scores of 15 employees enrolled in a CPR training course listed below. Okay, I'm going to sort these 15 data points for you just to move a little faster in this lecture. So if I put them in order, I should have 5, 7, 9, 10, 11, 13, 14, 15, 16, 17, 18, another 18, 20, 21, and 37. All right, so I have 15 data points. I've sorted them. They're in that proper order. So if I want to get to the mean first, I'm adding up all my data. it adds up to 231, and I divide it by 15 data points, and that will give me an average, a mean of 15.4. Okay, my median, so to get to my median, I'm taking the 15, adding 1, dividing by 2. So I know that 16 divided by 2 puts me in the 8th position. So 1, 2, 3, 4, 5, 6, 7, and 8. So right here, 8th position, this is the median, or my Q2. Okay, my first quartile. Since I have an odd amount of data, I'm looking at the data that is to the left of that median. So if I block this out, that is 7 data points. So if I take 7, add 1, divide by 2, 8 divided by 2 puts me in the 4th position. So right here would be my Q1, my first quartile. And then I do the same thing to the right. So I know that if I block out the median, there's 7 data points to the right. Right, add 1, divide by 2, 4th position is my Q3. All right, so the Q1 is 10, the Q3 is 18. Okay, this right here is the min and the max. All right, so my range is the difference between the max and the min. So 37 minus 5 gets me 32. My IQR, or interquartile range, is the difference between those quartiles. So here I'd have 18 minus 10, which would be 8. Okay, I've already drawn you a number line, so I'm going to start by plotting that 5-number summary. So my minimum is 5. I'll put a little dot here. My Q1 is 10. My median is 15, my Q3 is 18, and my max is 37. Right? It already is starting to look like that 37 is a potential outlier. Okay, next thing I'm going to do is draw my box. So here, 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 and here. Okay, add in the whiskers. Okay, and then also the median. Okay, should look like this. Again, this is the min, Q1, median, Q3, and the max. So before I even calculate for an outlier, I'm really looking at my box, right? I know that that spans 8 units. So if I multiply by 1.5, that means it needs to be 12 units wide. So about like that. And I'm going to attach to my Q3 and my Q1. And anything beyond those goalposts is an outlier. So let's actually calculate that. So my lower boundary would be Q1 minus 1.5 times the IQR. So if I plug in, that means 10 minus 1.5 times 8. So 10, let me show you how to plug it in. So 10 minus 1.5 times 8, like that, gets me -2. So that would be my lower boundary. So that is a goalpost. Anything below that, anything below would be an outlier. Right, so clearly I do not, if I go back, I don't have anything that is over in here in my data. Okay, then we look at the upper boundary. So Q3 plus 1.5 times the IQR. So here I'm looking at 18 plus 1.5 times 8. Okay, ends up being 30. So anything that is above 30 is an outlier. So if I go back to my data, let me just slide it up for a moment, I see that I do have one data point above 30. That's the 37. So 37 is an outlier. Right? So think of these two values as goalposts. Anything that falls beyond, that is an outlier. So anything that is less than -2 or above 30 would be an outlier. So now I'm saying, well, what would my graphic look like if I redrew it, pulling that outlier? So if I rewrite my data in order, I have 5, 7, 9, 10, 11, 13, 14, 15, 16, 17, 18, 18, 20, and 21. Right, I've pulled that 37. Now I have 14 data points. So my mean now, my sum is now 194. I divide it by 14, I get about 13.86 as my average. My median, right, take the 14, add 1, divide by 2. So 15 divided by 2 is 7.5. So I'm looking for the average of what's in the 7th and 8th positions. 1, 2, 3, 4, 5, 6, 7. Here's 8. So my median must be 14.5. Okay, then looking at the Q1, so I go to that line. I have 7 data points here. So I add 1, divide by 2. 4th position is a 10. Do the same thing to the right. 4th position is an 18. Right, here's the min, here's the max. So my range, the max minus the min, 21 minus 5 is now 16, half of what it was originally. And my IQR, 18 minus 10, stayed the same. Right, so if I go back to my original, right, my range, highly influenced by an outlier, it's now cut in half from what it was originally. But since the IQR focuses on what's in the middle, it stayed the same. So if I replot those points, I have a 5 for the min, I have a 10 for the Q1, I have a 14.5 for the median, I have an 18 for the Q1, and I have a 21 now for the max. So if I redraw it, there's my box. Here are my whiskers. Right, there's my median. Now we often use some sort of symbol to note that there was an outlier. So right here at 37, right, that was our outlier that we pulled. But when I look back at my original graph, this looks like it's pretty skewed to the right, potentially. But once we pull that outlier, it no longer appears that way, right? That outlier is what was making it look skewed to the right when it's actually not, right? Without it, right, I see that my data is pretty evenly distributed in each of these regions, but more tightly concentrated here in that upper region between 18 and 21. All right, flip it over to the back. All right, it's important to identify outliers for several reasons. Might be inaccurate data values. Maybe we had someone have a recording error. They recorded a value as 50 instead of 500, right? They lost a 0. Maybe the measuring device broke down. Maybe someone gave us a silly response, like taking a class survey, claiming to study 10 hours per night. So it could just be that we have goofy data. Maybe someone recorded it wrong. Might truly be a remarkable occurrence. So for example, in a graph of career basketball earnings, LeBron James could be our outlier. He makes a lot of money. He stands out. Okay, or in 3, we just need to acknowledge that an outlier's presence, regardless of the reason, can heavily influence the values of some summary statistics. An extremely high or low value that deviates from the rest has a big impact on the mean, the range, and the standard deviation. These are highly influenced by the presence of outliers. Okay, let's do one more example and I'll make it quick. I've already sorted it for you. So we have the number of days that 20 patients remain hospitalized. And we see that it spans from 3 to 14. And again, I have it already in order. So my mean, if I add those up, it sums to 142. I divide it by 20. The average is 7.1. My median, take that 20 plus 1, divide by 2, right? That would give me 10.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I'm looking at the average of what's in the 10th and 11th positions. If I average those two 6s, it's got to be 6, right? That is my median. Okay, to the left, right, that's 10 data points. Add 1, divide by 2. 11 over 2 is 5.5. So 1, 2, 3, 4, 5, and 6. I need the average of 5 and 6, which is 5.5. That is the Q1. Okay, and then over here, same thing. 1, 2, 3, 4, 5, and 6. Average, 8.5. That's the Q3. Okay, the range, what's the difference between the high and the low, the max and the min? So 14 minus 3 is 11. And then the IQR, the difference between the quartiles, 8.5 minus 5.5 is 3. All right, do we have any outliers? Let me slide this up. So if I do, I'm looking at that lower boundary. I'll just say low here. So I'm looking at that Q1, 5.5, minus 1.5 times the IQR of 3. And 5.5 minus 4.5 is 1. So any data point below 1 would be an outlier. The upper boundary, 8.5, that's my Q3, plus 1.5 times 3, that's my IQR. So 8.5 plus 4.5 gets me 13. So if I go back to my data, I see, oh, that 14, that's an outlier. It's above 13. If I had a data point at 13, not actually an outlier. We'd still put eyes on it, but we're looking at something that comes in above this value, not equal to this value. So 14 is my outlier. All right, so if I pull it and I look at my data again, let me write it out quickly. 3, 4, 4, 5, 5. I have 6 6s, 2 7s, 2 8s, 9, 10, and 2 11s. So if I recalculate my mean, my sum is 128. Now I'm dividing by 19. Right, I have 19 data points. That'll get me a new average of 6.74. My median, so if I take 19, add 1, divide by 2, I'm looking at the 10th position. So it's this 6 right here. There's my median. My Q1, right, block this out. I have 9 data points to the left. Add 1, divide by 2. I'm looking at the 5th position. Happens to have a value of 5. Okay, to the right, 5th position has a value of 8. So my range now, max minus min, 11 minus 3 becomes 8. And my IQR, the Q1 minus the Q3 minus the Q1, 8 minus 5 is 3. So again, big influence on the range, not on the IQR. Last thing to do is just to visualize it. And I like to show you side by side what it looks like as a histogram versus a box plot. So here I'm going to go back to my original data. I'm going to make an original histogram right here. So values that are between 3 and 4, because remember this is saying 3 to just below 5. I have 3 of them. 5 to just below 7, so I'm looking at my 5s and 6s. I have 8 of them. Okay, 7s and 8s, I have 4 of them. Okay, 9s and 10s, I have 2. 11s and 12s, also 2. 13 and 14, I just have the 1. So again, I'm looking at my original data. This is what it looks like as a histogram. So clearly unimodal and skew to the right. Okay, now normally I like you to look at the data both ways. What does your box plot look like originally? What does it look like when we've pulled the outlier? So let's look at this case when we've pulled the outlier. Let's look at that second set of calculations here for the 5-number summary. So here I'm going to look at the min of 3, okay, the Q1 of 5, okay, the median of 6, the Q3 of 8, the max of 11, but acknowledge that there was an outlier over here at 14. So here when I connect my dots to make my box plot, this is what it looks like. Okay, and I've pulled the outlier, right? But I've still acknowledged that there was an outlier in this data set right here at 14. But now if I go back to my box plot and what it's showing me in relation to the histogram, so remember here is the biggest concentration of data, right here, 5s and 6s, and we see that as it translates to the histogram, right? The more spread out we see for between the median and that Q3, right, that translates to the region that's like right in here. And then we see that this upper half of data is more spread out than that lower half of data. And that makes sense because we see that tail leading us to the right. Okay, so it's important to see it side by side to really understand that you see more nuance, more detail in the histogram, but the box plot helps you to see how concentrated data is in each of those quarters. All right, have a good day.